Good morning, everyone. Just waiting for some participants to join here. We can see the numbers going up, which is nice. I want to thank you all for coming along and taking part in this webinar. And we know that there's people from all around the world, so thank you for either waking up early or staying up late to join us.
And yeah, we're just going to got everyone joining the session now. It's great to see. So yeah, we're going to be covering fire suppression in power generation. So we're going to be looking at different areas. We're going to be looking at static power generation, a more traditional approach, which is generators that most of us are fairly familiar with. Then we'll be looking at another case study, like as an example, as wind turbines. Going to be looking at some different fire suppression technologies, different agents. All have their different uses depending on the application and the environment that we're protecting. So yeah, it's going to be a good webinar.
Yeah, and we'll just give it another minute, make sure we get everyone on board, and then we'll make a start. But yeah, we hope everyone goes away with a bit more of an understanding of how to provide automatic fire suppression systems for your power generation device, which again, that can range from a small battery charging station, energy storage system, wind turbine, power generation as one of the mobile power generators. So there's lots of areas in this arena. So we wanted to really give everyone a nice, thorough understanding, but not go into too much detail. So that's for us to get in touch with you and answer your questions later on.
All right, so we're going to go ahead now and share the screen. The way our presentation or webinars run is we'll run through the presentation. If you can leave any questions in the Q&A button down the bottom of your screen, and when we get to the end of the session, we'll open the floor for questions. And then if there's questions we can't answer or it's about a different subject, then just leave your name and your contact details in there, and Ed or one of the members of the team will be in contact after the presentation. Okay, right, so I'm just going to go ahead and share the screen. Okay.
Great. Okay, so yeah, thank you for joining us. This is going to be our webinar on power generation, directly related to our automatic fire suppression systems that Reacton offer. To do the introductions, I'm Ed Chivers. I'm the Global Product and Certification Director for Reacton.
And I'm the Chief Technology Officer for Reacton Fire Suppression. And
yeah, today we're going to go through the essentials. As I mentioned earlier, we don't want to go into huge amounts of detail. Just want to give you an understanding of the systems that are out there, what they mean and how they protect your critical asset. So what we want to talk about first of all is what is automatic fire suppression when it's related to the power generation. So it's a system that can provide the firefighting performance which can either suppress or extinguish the fire associated with your power generation. When we mention about suppressing or extinguishing, we want to educate people that we can allow for safe egress times in certain environments, but with the power generation, we're looking to extinguish because of the remote locations that we have there. And because of the remote locations, it takes a lot longer for the fire rescue services or anyone to intervene. And that leads us on here where we've got systems are fully autonomous, which is the automatic, and they trigger the system without any need for human intervention at all. These systems that we provide are applied in a total flood or local application method because we're using different extinguishing mediums. They have different ways of being applied. And the technology that Reacton uses is pre-engineered, and that means it's a pre-tested package which has a set parameter with it, and if you keep within those limits, you have an approved system. So there's no complex hydraulic calculations or anything like that need to be done. So they're very well accepted in the industry. And yeah, on the last bit there, we're just talking about really, if you wanted to boil down what an automatic fire suppression system is, it's basically a means of detection, extinction agent storage, and delivery.
And I think what we're going to find in this presentation, and it's particularly, it's quite unique to the power generation industry. There are other industries where assets are obviously very critical, but what you find in traditional power generation setups is, and we often see this in the UK and abroad, where you've got your power generation system, while it is a fairly typical layout like the one on the right here, we've just got a standard generator in a 20-foot ISO container. The downtime associated with damage caused by fire is much, is much more extreme with power generation. So a lot of cases don't have backup facilities for remote power generation. Often a lot of standby generators don't have a secondary standby. Again, it dictates the difference. If an automatic fire suppression system is fitted, it's likely the fire is extinguished, detected and extinguished without any real damage to the machine, other than obviously the component that potentially started the fire. And then that leads to the difference in time between a repair or a complete replacement. And as those that know that are in the power generation industry joining us today, a replacement, especially for specialist voltages or specialist applications, is a lengthy replacement time. And then when you look on the other hand and you look at windmills, for example, or turbine power, replacement programs are years. You know, it's full-blown remanufacture the unit, the specialist lifting equipment to put the nacelle tile back in place. It's huge, you know, and I think today that's probably what we're really looking at, is we're looking at mitigation of damage and the minimisation of downtime on power generation systems.
Yeah, and we've got some facts and figures later which will really bring it home about how much, especially wind turbine downtime and replacements can be. And then the last point on this slide here is the agents, the extinction agents that are used are tested for those environments, and that makes up part of your pre-engineered package. So this slide really is just a quick overview of what does a typical automatic fire suppression system look like. We broke it down into these main categories where we've got extinction agent storage system, which is essentially a cylinder there, and then we have the detection system. From Reacton, we have the detection tube, which is shown on the bottom there. We have a couple of different versions, but it's not just based on the pneumatic detection tube. There is other options, which we will discuss later. A distribution network, which is essentially your piping system or discharge hoses leading up to your nozzle, and then your actuation system, which we've got our CTX indirect patented valve, which it provides the control of the system using a pressure loss function. And then we have ancillary functions and equipment such as manual actuators or battery isolation or any sort of monitoring. We have a host of products that we can support you with on that.
Yeah, and one of the things that is important for the power generation is the remote monitoring. So we've got some modules that we talked about in the previous webinars that are coming to market shortly, and that will give us the ability to remote monitor these systems, again giving early warning to local authorities or system maintainers that there's been an issue. But for us, it's also the ease of maintenance. You know, to inspect systems that are very remote, those that are in wind turbines or remote power generation units, container generators. The ability to remote monitor these systems means that you're minimising on the manual inspections you need for the maintenance periods.
Okay, so we quickly move on to why power generation systems need automatic fire suppression systems. So really, it's we're protected against fire here. I know normally we always say that protecting life is our main priority. That doesn't change, but in these applications, they're typically not manned, so I've not mentioned on this slide. But the devices, regardless of their size, more than often are remotely located, and they're expected to work all the time, no interruption, continuous power to your business or whatever you're using that power supply for. And then there's no real chance of human intervention to even notify that there's a fire if they know what they're looking for, but also to attempt to tackle it. So when they do catch fire, it's usually devastating. And the total loss of the asset could be devastating for the business, but it's the downtime as well. That's something that's very important to look at. And as the word power generation covers quite a lot of sort of areas. One of them was the renewable energy power generation. Lots of different methods and forms that appears in the marketplace, but that's increasing in popularity. More of the population are becoming reliant on this and the service that it provides for those infrastructures. So people need this, and they can't afford to have downtime from these power generation devices. And then we've got the last point here, which talks about the harsh environments. And this really does lead us to having the automatic fire suppression system with the burst tube technology, the pneumatic detection, because of the environments. If you imagine a wind turbine, you've got harsh operating conditions, and you can't afford to have false alarms. You can't be going back up to that to replace it and everything like that. So you will find, as this webinar continues, you will see that these systems are really the go-to answer for the wind turbines especially.
And they're proven systems. They're used in a number of manufacturers currently of wind turbines. We're just talking about wind turbines. I think the other thing about wind turbines that a lot of people forget is when we're looking at conventional fire systems that are on like heavy vehicle fire suppression, from mining through to recycling, through to vehicle fire protection systems for buses. Again, wind turbines actually have, albeit a different combination of components, but still have the same issue of the combination of risks that exist in there. You've got a large brake that is used to stall the turbine and lock the turbine in position. You've got hydraulic circuits that deal with the blade orientation, the tip orientation you can see in the top right-hand corner, and the pitch of the blades is all controlled hydraulically. So you've got hydraulics, you've got hydraulic motor. You've obviously got the electrical generation side, so you've got the motor generator in there, you've got the control equipment for the motor generator, you've got grease and oil for lubrication of bearings on the wind turbine, and you've got a hot environment that it all works in. So I think there may be an opinion in some cases that wind turbines inside a very clean, sterile, scientific, clever bits of kit, but in reality, what they are inside is very similar to other common fire assets or fires that we see in assets on the ground, and have the same combination of combustible materials that exist in them, and as I said, the same risks. So the way we approach fire suppression in wind turbines is unique because there's different risks, but the risk of fire still exists in the same manner that they do with other power generation applications.
Yeah, and just before we play the video, I know on the previous slide I had a point about them always being remote located. You've got to understand that if there's a mobile power generator and it's next to your building, the risk then spreads to your building as well. So it's not just the value of that power generator being, a total loss. It can extend to your business, the actual the building or anything that's associated with it. So that's one thing to bear in mind, which again often gets overlooked. People just place these 20-foot containers, 40-foot containers, and go, I've got suppression in there, that's okay, but they haven't looked at the risk of it, what it's adjoining or it's located next to. This video here really is just going to show you an example of a fire condition, what happens if you don't have fire suppression in your wind turbine. Again, just to sort of look at the scale, these fires obviously escalate very quickly. They're unable for fire brigades and everything to get to quickly. They're usually located, either high up or out in sea, or in areas which are not easy to access, and they are very high up as well. Yeah. And you've got a lovely supply of air to as well.
It's really surprising, actually, guys. Before we say this, play this video, a lot of the fire that you see, or the combustible material you see here, a lot of it is hydraulic oil. And not a lot of people realise just how much hydraulics actually exist in the large majority of wind turbines. So you can see, just by playing the video, you can see that this fire is well established, and you can now start to see the breakup of the wind turbine. And there's various different causes of wind turbine fires. We're not going to go into that detail today. It's widely published on the internet about various causes, but traditionally a lot of them tend to stem from brake failure or heat brake fires, where the wind turbine pitch control fails. And so that's the hydraulic circuit that controls the pitch of the blades, and if that fails and you get a high wind condition, it's down to the job of the brake that on the rotor that stops the fire, that stops the wind turbine. But obviously, as you know, the power of the wind with a blade that's very pitched and stuck in pitch will struggle to stop it. So that's an example of one condition that can happen, and you have a build-up of heat. The heat has nowhere to go, and then results in what we've just witnessed.
This video here is just really showing you the aftermath of what happens in one, and these are not cheap bits of kit, and they're not quick to put back up into service. So really, it just gives you an idea of how damaging it can be. And like Ed mentioned and touched on, there are multiple reasons for these catching fire, but one thing that is not in question is they do catch fire quite a lot. So, for a small investment compared to the total cost of the unit, you can mitigate these risks.
And this is a good video because it shows you the sort of build-up, it shows you sort of the makeup of the wind turbine. And most of the wind turbines are made from a lightweight material, but here you can see the inner workings of what we're talking about. So I was going to try and see if I could be clever and spot some components that we were talking about. So what you've got here is this is the main generator that you see here. Hopefully you guys can see my mouse. So this is the main generator here, and this is the cooling fan for the main generator. So this basically, in here you've got a driven fan. This keeps the motor cool. So that's located here. Forward of that, you've got all the pitch control for the blades. See if I can get a better view. Here we are. So here you can see, this is a great shot. So here you can see, this is the cooling area for the motor. This is the actual generator. Here's your transmission for the gearing back into the generator. And then what you have on the outside of here, you can't really see it probably very clearly, but this is the pitch control for the blades. So this controls the rotation of the blades. And then somewhere in this quite a lot of mess that you have here, probably around this area, will be the brake that exists for the wind turbine. So you've got a real, there it is. So you've got a real mixture of quite hazardous scenarios that can occur up here, very high off the ground with no support. So once a fire is established, there is no way you're going to prevent the fire from spreading. So the only way to mitigate fires in wind turbines is to fit a fully automatic fire suppression system that has been designed to extinguish all of the fire risks that can exist. There's no point designing a system in this type of wind turbine that is just protecting one area. We need to look at a holistic risk assessment that looks at every area of the wind turbine and then manages and mitigates those risks with the system. I'll let this play out while you talk.
Yeah, and it's a perfect environment of electronics. You've got power generation there, you've got lubricants and hydraulic oils. Also, you've got that great friction force for the braking, which generates heat, and there's a lot of conditions that can all work together to create these fires, and that's why the systems we look at, they need to be able to cover your Class A, Class B and C risks.
There's a control panel, sorry Ed. There's a control panel here. It's been burnt out.
Yeah. So the systems we offer are designed for that. They're proven. We use extinguishing agents that have really gone through the most approved agents in the market, really. So we'll touch on that in a minute.
Okay, that's a good video. Shows you the.
So leading on from those images that you saw there, we've got some pretty striking facts here about the statistics surrounding the fires. So 90% of wind turbine fires result in total loss of the turbine, and if you imagine each one of those, $4.5 million for the cost for an incident. You've got to think of the people that are involved to get that back up and running. It's not just the fact that that's the cost of the unit, it's where it's located. The people need to be trained to work at height, to transport the equipment, to get it to there. It's there's a lot that goes with it. 900 litres of lubricating oil. So this is something a lot of people wouldn't really realise, that you would have that much. You think that's a considerable amount of fuel to have in an area which could get struck by lightning. It can have electrical faults, obviously the high heat from the braking. So it's got the perfect conditions to start a fire. Here we've got 37% fires due to defective parts, and then on the last one, I think we've got when we said that these do happen a lot, 91% of wind turbine fires aren't reported there. So that's massive. So there are lots of supporting documents out there, really in-depth studies about this, but a lot of them aren't actually publicly reported there. So the true picture that some people see, well, it's not correct.
Yeah, and that's not uncommon. That's not common for most specialist industries not to report fires. It's something that we're actively trying to work with insurers to promote a more open basis for the pattern of identifying what machines catch fire the most, what's the cause of the fires. And it's just something that we really struggle with. I know Australia's done well with its with the bus reporting system for fires in Australia, so they've got some really good data on how bus fires occur, and that's been a joint effort between manufacturers, regulatory bodies over there, such as like the Transport Authority. So we need more of that in the industry to be able to make sure that not only can we design and engineer systems better, but we can also work with manufacturers to mitigate the risks at manufacturing. It's still a common problem we see, is that even in any application that designers work to, they want the product to perform well, they want this, they want that as part of their main spec, but very often the fire mitigation is overlooked. So it's something that definitely we advocates of and want to try and keep promoting.
What we have here is quite a basic sort of comparison. It's relatively generic here, but we're talking about the automatic fire suppression system. So one from Reacton, say, handheld portable extinguisher, and then a sprinkler system. What I wanted to get out of the way first is the point at the bottom there that, really sprinkler systems aren't really a viable option for the wind turbines or even your mobile generators or anything, because they're mobile. The sprinkler systems usually for your building and anything like that. So it's not really the best comparison there to have. But what I wanted to show is that the automatic fire suppression system doesn't need any human intervention for it to work. It can automatically provide shutdown and alert and notifications to people. It's suppression exactly where the fire starts. And that can be as detailed as going into the electrical panel inside the wind turbine. So we could go right down to a very low level there of protecting it right at the source. Minimal damage. because the agents we use and we're detecting it so early, you don't have to worry about it being applied correctly like you would with a handheld. It's pre-engineered, it's designed to do what it does, and you're not relying on someone to be able to aim a fire extinguisher and use the correct fire extinguisher, which is something we all know can happen. And then you've got pretty much the full-time protection, 24/7, 365. So it's an all-rounder and really the sensible choice for your power generation. Okay. So on this slide, we're now moving over to talking about the actual agents the extinguishing agents that are used. And when we talk about Reacton's clean agents, we're only referring to the chemical gases or synthetic gases, which are the 3M Novec fire protection fluid, which you can see here, the top right hand, we've got a direct system with the tube shown and an indirect, just a typical one. And then below that, we've got the FM200 waterless fire suppressing from Chemours, again, available in the exact same range and size, direct and indirect. So most of the people are well versed in what clean agents are and how they work, but we've got a nice run through on the side here about the rapid fire protection. Typically they're designed 6 to 10 seconds for the indirect to discharge, zero cleanup, no electrically non-conductive, ideal for sensitive electronics, non-corrosive, zero ozone depletion potential, covers A, B and C fire classifications, low space requirements compared to other solutions. We have the two variants, direct and indirect. And then the agents, as I mentioned before, we use agents that are tried and tested and from the biggest names in the industry. And they all have the UL, ULC, FM listings and approvals all through, and the SNAP listed. So that covers the clean agents from Reacton. And then we have the dual agent system here. And people who have worked with Reacton before, who will hear this when we talk about our vehicle fire protection systems. They're exactly the same as what we can use for the power generations. Essentially in the mobile generators, you've got an engine in a compartment that needs protection. And we know that the dual agent system offers just the highest level of performance. It's made up from a dry powder or dry chemical system along with a wet chemical. They're tested, configured for significant leakage and ventilation. And actually from our testing, you could have essentially an engine in the middle of a field and still protect it, even with high airflow. And that's something that we evaluate when we go through our design criteria and risk assessments. But if I just go through the extinguishing agents that are used, we've got dry powder, fast fire knockdown, 5 times more effective than water by weight, superior coverage. Then we have the wet chemical side, which provides the excellent cooling and therefore reignition protection, but also it will create a barrier over the fuel that's leaked. And we use a wet chemical that is obviously comes out as a liquid based and free flowing, so it follows the same path as a fuel leak. So we'll find that, and then it has a nice blanket over there. So that's all done intentionally. And then the fact of having these two agents, you get all the advantages from both mediums in a single solution, highest level of protection, as I mentioned, and then it's very economical compared to just a wet chemical or liquid-based system. And then just to sort of give you a little fact at the end there, Reacton systems start as small as a 4 kilo powder and 4 kilo wet chemical. It's important to know that they will actually carry an approval as well. They have both SPCR 183 and 199, and please get in touch if you want to know more details about those, because I don't cover the approvals in this this webinar today.
And I think, yeah, it's probably worth going through, because really it's probably worth saying that what we're saying is that where we have an electrical only real risk, main risk, that's where we're looking at clean agent. And where we're looking at the dry chemical and wet chemical systems is when we have larger diesel engine generators as being the primary driven sort of source. That's the comparison that we're doing. Right, so let's walk through this.
Yeah, so the image you see in front of you here is just a nice example of a system. And these are actually available on our website as well. It tries to give the customer much more of an engaging overview of what's involved. So we'll talk through these quickly here. The systems that we provide have a pressure switch. These could be configured to close the ventilation. As you can see on here, we've got some openings. You might have a fire damper, seal it off so you can do a total flood with a clean agent in there. It can also give alerts to people through separate control panels or anything like that. The Reacton detection tube, we actually cover that in a minute, but this is ideal for these harsh environments, but it still offers the reliable and fast detection.
Okay.
Then we have in this example, it's a clean agent one. We've got a clean agent nozzle, which is all stainless steel, and are designed to disperse the agent in a controlled manner and get the coverage. And on this one, we've got a manual actuator here. Obviously, it allows someone to manually actuate your system if they notify that they're notified that there's a fire, and for some reason it's not gone off, or they're very early stages. They can manually actuate that, but it can also be used as a commissioning point. It allows you to charge the system. It allows you to monitor the pressure. So
yeah, and it's important, the manual actuation point, because it gives a lot of operators peace of mind, because when we, in our experience talking to people, if you say it's fully automatic, and I'm talking about more mobile assets like the one we've got on the screen, people like to have the option of being able to manually actuate the system if they feel the need arises. So it's a great add-on, and it's actually a really inexpensive add-on to the system. It's really, a very small value comparative to the rest of the system. So let's skip to the next slide, hopefully, if it will let us. There we go.
And this one here, we've got a typical solution here from Reacton, and really it's just to give you a taste. This isn't a physical installation here, and we've got more of a direct drive wind turbine there, which isn't as traditional as some of the others we've seen in the videos. But what we're trying to highlight is that we have systems that are able to provide protection inside those cabinets, which could be, they could be quite sealed from the rest of the room, and you may want to just say, I want protection just in there. So if that goes off, you're only replacing a 1 or 2 kilo system rather than the more of the total flood system protecting the rest of the area. So some people like to have them configured that way, and we like to give the customer the options, and they can decide how they want to have that. So it's really just to give you an idea of the scale of the cylinders compared to the actual wind turbine, and some of the solutions there. Here we've got, this is a quick video about the burst tube, or the pneumatic detection tube. It's 100% pneumatic, no electricity required at all to operate. So that is something that we've had great success from, where people they don't have that worry, that sort of issue of what happens if I have a power failure there, or someone breaks a cable leading to your actuator or whatever. Don't have those issues. The default setting for a pressure loss system is for it to operate when it catches fire. So it by its nature, it's designed to go off in a fire environment there. Minimal false alarms, not affected by dust and debris and smoke, which again you can get quite a lot of in a mobile generator or a wind turbine. They're robust, but also very reliable and sensitive. Quick to root and fix and install. Everyone who's done that will be able to to mention how easy these systems are to route. And essentially, you get a detection point wherever that tube is routed.
And I think, and I think the point being is that you look at detection technologies, and we have a number available to us, but whenever we enter into a new service or a new application or a new installation, we always come back to this technology, because we've developed the technology over the years so that we don't have the false discharges that some people are akin to the detection tube technology. And you cannot argue the reliability of it. You know, it's one single moving part in the valve, and you can't not have the system go off if you release pressure in the tube. So for us, it is for us, we like it not because it's a cheap or easy to engineer product. In fact, it's actually a lot more difficult to engineer a pressure loss system correctly so that it holds its pressure correctly over its lifespan. You don't have false activations, but the reliability is unbeatable. So that's why we. And what we're showing here, just on repeat, is ignore the agent coming out of the tube. That's more for a control panel system, but you can see how the tube ruptures and reacts when it's exposed to a flame. So the tube ruptures, it forms a blister, and then that releases the pressure inside. But this particular system has an agent filled in the tube, and this is one of the technologies we have for control panel systems that discharges from the tube, as opposed to nozzles that are placed strategically throughout the asset. So we're going to pick the pace up a little bit, because we've been timely with our webinar so far, so we're not going to fall behind.
Yeah, so just moving on from, we've covered the detection tube, which that last part of that slide, it said it's available in a red, a blue, a black. They have different grades and ambient temperatures, but the one you see here, the valve there, is the red tube. Again, it offers a purely pneumatic detection system, and our valve is obviously patented, but it allows us to have either a purely pneumatic detection system or a fully electric detection system, or combination of the two. So it's extremely flexible, and all the ports you see on the top there are available for pressure switches, or to have one of these solenoids added to it. We've got an internal ball valve inside of our indirect valve there, very nice and easy to isolate the system and lock off, and it allows customers to know that the system is isolated and it's locked in the functioning position, which is very important for when we do servicing and looking after the system. We've got an extensive range of electrical actuation methods. We can see one at the bottom there where we've got the solenoid attached to our solenoid adapter. These are very small solenoids. We've specially designed these for ourselves, and all this is doing is venting the chamber on the top of the valve, which allows the piston to move up. But we can have these solenoids located anywhere on the top of the port there, but also you can have them via an adapter on your manual actuator, on your end of line, or anywhere in your detection tube as well. So it allows you to have both electrical actuation and pneumatic in one system. So it covers both bases there, and we can go into more detail about that. Here we've got, again, this is really looking more towards sort of the wind turbine side, is the improvements that we can offer and solutions that Reacton can offer for improvements in your maintenance. Anyone who's familiar with clean agent systems, you know that you have to maintain and inspect these at regular intervals. And part of that is actually confirming the contents. And a typical process is to weigh the system. And before you weigh a system, you obviously have to make sure it's safe, disconnect it, and then obviously weigh it. So there's a lot of downtime associated with that, and a lot of risk as well, because these are pressurized vessels, and you may need two people. And when you put all of that at 300 meters up in the air with specially trained people, it starts getting very expensive, and there needs to be a better way of doing it. And this is where you've got the ultrasonic liquid leveling here from Cold Traco, where we can verify the agent contents. It's fully portable, very easy to use and operate, and it gets rid of all those safety concerns that you had from disconnecting the systems. One person, so again, you're saving on the cost of having multiple people at height. Covers all of the codes and regulations, and there's lots that they offer there as well, where you can have it so it remembers your last service, and you can quickly refer to it to see if there's any changes in your weight, and be able to understand your inspection much more detailed, and it's in your hand, it's there. So wanted to put this one out there to let people know that we're always looking to make it as easy as possible for the customer to maintain the system.
Yeah. Okay.
And we're getting towards the end now, and we've got really, we'll go through how the system works here. We've got a small video at the end as well, but really we've got a fire, and that can start from a multitude of different sort of ways. It could be electric fault, it could be a lightning strike, short circuit, burst fuel hose, spraying onto hot surface, all those. So you have a fire, the radiant heat from that fire will then burst the detection tube or activate fire suppression through, if you've got an electrical detection system attached to it. In direct form, the tube bursts initiate the discharge at the source of the fire, and then with an indirect, the extinction agent is delivered through your discharge network, and that comes out through the nozzles, and it provides fire suppression for that entire hazard there. And then as a result of that, it can either confirm a discharge through a positive pressure, and that can shut down fans. It can also stop the power or anything like that, but also you can send signals to alert people that there's been a fire in that environment.
And then the video we've got next is a test video that's actually for some of our vehicle systems, but it's very much, it's a good demonstration. Again, it's a video that looks at combustible fuel with an airflow going through it, and just shows, it's just a good video to show you some of the testing that we do with these various systems. This particular system would be more closely related to diesel generators. So this is like a typical, if you imagine a typical diesel engine sized, something like 150 kVA generator, 200 kVA generator size. And then you can just see basically the enclosure is totally open. So again, you get generators with full enclosures, or you get generators that are standalone with no external cowling on them. And it's just a good video to see how fire dynamics change when you add fuel and airflow. So we've got some fire pans here lit, and as the fire and the heat builds, obviously the intensity of the boiling off of the heptane fluid that's in those pans increases. And then what we do is we add an airflow. So this is simulating a cooling fan at the front of a gen set or another application. So you can see very quickly that as the airflow increases, it changes the dynamics of the fire. It also increases the white heat that you see in this area. And then we add a liquid spray that you can now see that's fueled the fire even further. And then at 2 minutes, we manually activate the system while the diesel spray and fan continues. So what we're testing for here is we're seeing no reignition. We continue the discharge of the dry chemical for around about 10 seconds. And then we have a wet chemical system that's cooling the hot parts or simulated manifold and turbocharger area of the machine. You still have diesel heptane mix, so petrol and diesel spraying into the enclosure. The cooling fan is still on. So as Ed added earlier, that we would traditionally shut down an engine. What we do is we test for the worst case scenario. We keep the engine running and we keep the diesel spraying in this test. And you can see that there was no reignition of the fire despite the cooling fan and heptane still spraying.
Yeah, and it just showcases the performance of the system in a totally open environment there with high airflow. So it's got all the real hard bits associated with it, but it performs. And that's a high load fire condition. So that's the hardest one there to pass, but we did it without any enclosure around it as well. So, and that's very important when you're actually designing the system. Here we're just talking about the components. So the great thing about the Reacton product is, regardless of the type of system you use, so whether it's for vehicles or it's for kitchen or for electrical cabinets, the valve is actually the same unit, and those valves and the equipment brackets, all those bits have all gone through some extreme testing, and we've got the testing that we've gone through with the Research Institutes of Sweden, where it's extreme temperature cycling, then vibration, and then you've got the corrosion. And just to give you an idea, we've got a nice video here of the actual vibration chamber. And the systems are on this for 96 hours. And that's after they've been temperature cycled from -40 to +80. And even after all of this, they then go through 5,060 shocks at 10 and 20 G. And then you have to discharge the system and ensure that you get enough of the contents out. Just to give you an idea of the performance of the system, our 9-kilo cylinder, after all of this extremely harsh treatment, it discharged all the agent apart from 6 grams of powder, which just shows you how effective it is. And here we can see that this one's obviously going in one of the axes here, and this is for 32 hours it will sit on that. The vibration is extremely harsh, and it's random as well. So it really does put the system through its paces, and it gives everyone the confidence that they're getting a system that can stand up to these environments. And then on this last slide, really, this is more obviously about what Reacton can offer you. And we know what our systems are capable of, and we know the testing and approvals behind it, but there's a lot more to do with a system from a company, and that is their support. You know, the world-class documentation. We pride ourselves on our manuals. They're very clear and concise, without removing detail, but to make it easy for people to understand. We've got a fresh look than what's normally in the industry. We have some world-class training. We've got these online platforms where you can see that we either have actual animations, we actually have videos of physical installs on real-life machines and assemblies of how to put things together. We have a communication platform, which again is online, allows our customers to talk to us 24/7, and they get real-time responses, which are all checked by everyone. So it's not just reliant on an email coming into office hours for the UK. We've got offices in the US and Dubai, so we get that much more of a 24/7 sort of offering. And then we've got our world-class animation, which if anyone's looked on our YouTube account or LinkedIn, you will see some of these, and we're constantly developing new ones, and we've got some really nice CNC and electrical panel ones coming up, and they are incredible, and we're very blessed to have our guy working with us who's a lot of time has gone into being able to do that. So and that leads us really onto the sort of past people, which I'll let Ed talk about.
Yeah, so, and I mean, Ed just mentioned there about the animations. The animations are great because they not only look great and make a good case when we're talking to people, but it helps people educate themselves on what the systems do and how they work, and it also helps training people to understand how systems work, what to expect when the system does activate, what areas we protect in the particular risks. And as Ed said, we've got some incredibly talented people that work in the organisation here and in the other offices around the world. So I think it's testament to our quality that we've always pushed for. Is we're not in the industry, and we don't exist to just provide a okay product, or we say that we're just here to suppress fires. We're here to design systems that regularly, safely extinguish fires in all of the scenarios that we put forward as a protected risk. So the R&D that goes in, the incredible people that we have working here, all contribute to the performance that we've seen, saving hundreds of vehicles and assets every year. That for us is why we come to work. You know, for us, it's what we like. We like hearing the stories where we have protected these assets and we have successfully extinguished fires. And to see the genuine thanks from customers and from distributors that have had customers that have had machines saved, for us is what we're all about. So, you know, that's why, again, we'd encourage after the session to engage with any of us, and there'll be a link that comes out at the end of this webinar so you can rewatch the webinar. There'll be contact details for everyone in the organisation as well for some more questions. But yeah, that's what we're about, really. So, right. So we're going to just stop sharing the screen now. Right, you can see us again. And let's just go through to our questions.
Yeah, and I think we do have a poll we can do as well.
Oh, do we? Okay.
Yeah, we can have that.
We like a poll. So let's, we'll fire up the poll first before we take questions.
And yeah, just feel free to answer those, obviously, as honestly as possible. It's great fact finding for us as well. And obviously it can drive a few more questions from the answers that you give there. But yeah, thank you for participating and going and watching our webinar there. And what we're trying to do now is answer the questions as quickly and clearly as possible. So,
okay, so first one. Just start reading through the question.
So I think really we've got a question there about the pneumatic tube. It is essentially a heat detector. It is classed as a heat detector. When you put that through any UL testing, it will be covered under the heat detection side. And all of, you know, it's there to obviously detect any radiant heat or fire, anything like that. But the secret with the detection tube is how it's installed. And that's one of the things that we spend a lot of time with people. So it's only as good as the person installing it. If you're installing that and it's not around risk areas, then you compromise detection time. And where we train our guys, we make sure that they're aware of airflows and anything else that's going on that could affect the detection time. And that allows you to pick how far away you have it from the risk. And in our technical manuals, we clearly advise these positions to have them. So we've got that covered there.
So this is a bit more of a specific question, which I think is from Harish, and we'll come to you with a bit more detail on this. The question is about what size of the megawatt capacity do we cover up to, and what's the feedback from OEMs and the actual loss history with gas suppression in place. So when we've been speaking to a number of OEMs for wind turbines, what's quite interesting is the highest capacity megawatt wind turbines don't tend to be the most specified wind turbine. So what you tend to find is the high volume wind turbines that the OEMs invest in an OEM fitment fire suppression system. They have good history with systems extinguishing fires, but again, the issue we have here is that OEMs are not willing to share the data that looks at what wind turbines have they lost without fire protection, what have been saved with fire protection. But all I would say on that comment is the fact that the amount of detail that we're going into with OEMs on wind turbines shows that they obviously work on the basis that it's now becoming a larger fitment on a larger range of wind turbines. And I think, you know, it's anything. There is the gas fire suppression side of things. If again, it goes down to how well the system's designed. So I think from a summary point of view with OEMs is at the start it maybe wasn't taken as seriously as it should have been. But now it's certainly very much something that all OEMs are being asked for. And it was interesting in the poll there that the top answer was that they wasn't aware it was available for wind turbines. And we find ourselves, as well as other OEMs, find ourselves having to keep educating the OEMs on the fact that they can fit a system at factory that can be shipped anywhere in the world that will protect the wind turbine. So we'll come back to you on a bit more detail about the megawatt capacity at the end of the webinar. One from P. So do insurance companies typically ask for fire suppression to be fitted to turbines, or is it a self-insure situation for a lot of them? It's a mix of both, Pete. So we've spoken to one insurer that insures a lot of wind turbines, and Edge mentioned earlier about control panels being protected. So they will stipulate that control panels need to be protected in the wind turbines, but they won't typically suggest the entire nap tower, the tower on top, or the main body of the wind turbine is protected. It goes back down to educating insurers. Last week I was educating another insurer on a vehicle application, a very, very big insurer, that still is moving into the market with vehicle fire suppression. And again, it just shows you that it's all about education about systems. The self-insure, guys, is interesting because it depends on the attitude of the person who's in charge of the self-insure situation. So you can either find a situation where it's a case of, I've never had a fire, I'm not going to have a fire, why do I need a fire suppression system? But those that have had a fire believe it's the best thing that they've ever come across. So it's always, it's unfortunately in that situation, again, we mentioned at the start of the presentation that we find it difficult because of the lack of data, and you have to be careful with the data source that you're relying on, as it can be influenced from people trying to sell fire suppression systems. I know we're one of them, but we try to remain impartial when we're looking at data. So, so for us, it's very difficult to get that kind of information. But by contacting them, you can get a gauge for where they sit with that particular question. Yes, so we did mention about the installation of tubing and how we only detect a Class C. So the tubing does require a heat above 130 degrees centigrade to activate. But what we did show you, in one of the presentations, was the option to connect it to an electronic actuation, an electronic detection source. So in some of the wind turbines, they will use a smoke detector, very traditional, or a sniffer, and the systems can be connected via electronic discharge. So we prefer the detection tube as either a primary, but if you want early detection, you connect it to an early detection system like a smoke or sniffer system, and then you can use the pneumatic tube again as a backup detection system.
Yeah, and I would strongly suggest, especially in the wind turbine environment, you have pneumatic heat detection there, because you're going to have high airflow. So even though your Class C fire might start off as a smolder in there, unless you've got an aspirating system that is collecting it at a point of where there's an extract or whatever, it's going to be very hard to detect that because of the high airflow that could be there and the other conditions where you get the false alarms. So this is why, as I mentioned at the start, the systems from Reacton with the pneumatic tube, typically the go-to product for wind turbines, because you would start dialing in a sensitivity that would give you too many false alarms, and then you get the problem which was mentioned earlier, where do we have any information about gas suppression systems failing? I'm pretty sure a lot of the failures that you see from any systems installed in a wind turbine is the fact that they've either already discharged or they were a low pressure condition. So it's not the actual effect of not being designed correctly or the agent not being the right choice. It's typically that they're not maintained adequately, or they're not ready to protect because they've already gone off on a false alarm. So that's where the Reacton detection tube systems are robust and really the go-to method for fire suppression there.
And it is a balance, you're absolutely right. It is a balance between early detection and false detection. If you're protecting a generator that's on the ground, a 50 kVA, 100 kVA generator that's on the ground, and you have a false activation, it's no problem. Get some new cylinders, fit new cylinders, and recommission the system. As Ed said, 300 meters in the air, carrying a 50 kilo, 20 kilo cylinder to the top of it, winching it using the internal crane to the top. It's an expensive exercise. So there is a real fine balance in the detection. And it's influenced by the environmental factors. You know, offshore, you've got the high corrosion potential with sea air. You've got dusty environments that they operate in. So there's a lot of false knowns for a aspirating system that could interfere with the detection, depending on where it's situated. So.
And yeah, like I said, we've got a system that can handle both. So you could have, if you wanted, like a double knock sort of situation, if you want that. So the good thing is the system that we offer can provide support for either method or the combination of the two.
Okay.
So, yeah.
All right. So as I said at the start of the webinar, you're going to get an email with all the contact details of everyone that's in the business that you need to speak to about the various topics covered. Add contact details will be in there. There'll be a copy of the presentation that you can rewind and look at the questions on. We'll send you out a link to the next webinar we've got coming up. And yeah, thanks very much for taking the time. Thanks very much for taking the time to view the webinar today. Really appreciate your time listening to us, and hopefully you gain some insight into what we do and some of the risks that we protect. And we're going to let you go now. We've kept you for an hour, so thank you very much from us here in the UK. And as I said, any contact details will come over, and any questions you've got, make sure you get them over to us, and we'll see you guys all soon.
Yep, thank you for your time, and stay safe.
Okay, thanks guys. Cheers.